Hello everyone, my name is Wu Shun, and today I will be presenting my EM3 assignment, which is about Euler's method. So for my EM3 assignment, I have been tasked to solve a differential equation using the Euler's method. The Euler's method basically works by approximating the value of a function at a point using the tangent line. So right here, I have drawn a diagram, for example, to show how I derive the formula for the Euler's method. So the curve right here is actually the solution of a differential equation, but is unknown. So assuming that only one point of the curve is known, which is xn, and correspondingly yn. In order to get to the next approximated point, you need to draw a tangent line on the already known point, and you basically follow this tangent line forward with a small step, which is your step size, as indicated by h down here. And you repeat the process until you get your approximated actual solution. So I use the formula of the gradient. I use a formula to calculate the gradient of the tangent, which is the change in y over the change in x. You make y2 the subject, and take note that the gradient of the tangent can be represented in this expression. And next, you substitute x2 minus x1 to be h, which is your step size, and x1 to be xn minus 1, and y1 to be yn minus 1, which is your current point, x2 to be xn, and y2 to be yn, which is your next point. So by substituting all this inside the previous equation, you get the formula of the Euler's method. So for my EM3 assignment, I need to solve this question, and I need to find the approximate value of y when x is equal to 1. So in my Excel spreadsheet, I have created 3 columns, one for x, one for y, and one for fxy. The column x represents the value of x increasing by 0.04, which is my chosen step size, and until it reaches 1. Of course, the smaller the step size you choose, the more accurate the final result will be. For the y column, it is the approximated value of the curve by using the Euler's method. So it's right here, the formula is right here. This is basically the Euler's method, same as this. And for the final column of fxy, this is a calculated value of the slope of the curve at each step by substituting with x and y values at each corresponding step into the differential equation in the question, which is this equation. So for example, for this step, I will choose the x and y value for this step and substitute it inside the equation to get the value, to get this value. And the formula for this column is basically this. So by solving the same question using the general solution method, we'll get the final answer of y to be this. This is the actual value. And to calculate an approximation error, you need to take the actual value minus the approximated value. So we'll take this value right here to minus this value right here. And we'll get the answer of 0.00156. So this is the approximation error. So that's it for my presentation. Thank you for watching.